All right, I'd like to welcome everybody here. Thanks for coming. My name is Denise Bernard, and I'm a volunteer with the UC Master Gardeners of Monterey and Santa Cruz counties. And we are welcoming you today to the program on resilient soil basics. So before we get started, we'll go ahead and do all of those typical Zoom things just to make sure we're all on the same page. Please keep your microphone muted while we have the presentation going on. And we ask that you also keep your video off. It helps the program run more smoothly and is much less distracting to have that. So if you go ahead and put that off too. We also recommend that you use a speaker view. You'll be able to see the slides the very best if you use that view. We'll be keeping our questions until the very end, or your questions, I should say. So please use the chat window. You can put them in there anytime during the presentation, and we'll just go ahead and hang on to them until the end and make sure they all get answered. If you have any technical questions, you can just send a quick chat to me, and we'll make sure we get you going and set up there. A couple of things we have set up for you as well is, I believe, our live script button. Do we have that going, Delise?
Let's make sure we do.
All right. Once we get that set, you'll be able to click on that and get a closed caption kind of action going if you'd like. And don't worry, we, as you might know, are recording this presentation, and we'll send the presentation and the link to the video to your email within a few days. So if you come in a minute or two late, don't worry, you're going to get everything. And something we'd like you to do this time particularly, we have a couple of questions that we'd like you to answer as we're going along. And you can go ahead and use the reactions button, which is also down at the bottom of your screen there, where you can raise your hand or celebrate. Mostly we're going to ask you to maybe raise your hand to answer a couple of questions as we go along so that we can tailor the presentation directly to you. All right, let's see. I'm not sure if we've got that. Still working on the live stream.
I can see mine. Can you guys see yours? I think there has been an upgrade to the app because
I'm not seeing it here. Hopefully it will show up as we go along.
Okay, if you have at the bottom of your screen a closed caption option, a button, go ahead and select that and you'll get the
if you'd like it.
Yeah.
All right.
Sorry about that.
Yeah, there's always a question there to go on there, something. So for anyone who isn't familiar with the UC Master Gardeners, we are a volunteer program, all volunteers. We've been around for, I need to look up the actual number, but it's definitely more than 40 years. We work in partnership with the Agriculture and Natural Resources Division of the University of California. We are all trained, and our mission is to provide outreach and research-based education on horticulture, pest management, and sustainable practices to home gardeners in our local communities. So now that you know a little bit about us, I'm going to go ahead and turn it over to our speakers for today, Debbie and Delise.
Okay. Hi, everyone. Can you hear me? Yes? Okay, great. I'll just introduce myself briefly. I'm a first-year Master Gardener. I was in the class of 2022. It was a great experience in taking the classes. I learned so much, and I've especially enjoyed the hands-on opportunities for the volunteers this year. So yeah, so I'm just getting started in this thing. I'm a retired geologist. My career was mainly in environmental consulting, where I worked a lot on environmental investigations and remediation of contaminated land. Prior to that, I also have some experience with biodynamic French intensive gardening techniques. And I think that was my first exposure to the concept of building healthy soils And that's really stayed with me. It's a concept that it just occurred to me working on this, that's where I first got that interest. So my interests include soil, composting, and other sustainability practices. So thanks, Delise.
We are so lucky to have Debbie added to this curriculum. So happy to have you. I am a Master Gardener since 2014. I've done many roles with the Master Gardener program, but I've been growing food, flowers, herbs, and perennials for so many years, just a long, long time. Always organic in my world. And I worked for Renee's Garden, that seed company that you may know of. You might have bought seeds from them at the hardware store. I have BAs in environmental studies and biology, and I love teaching these classes. And this is my absolute favorite topic. I'm just fascinated with soil. So thank you all for being here and letting us teach.
Okay, well, hi again. I'll take the first part of this presentation and get us started. Thank you for everyone joining today. And in preparing for this class, we're assuming that many of us, or most of us, are home gardeners, like Delise and myself, and we likely have some common experiences. For example, we want to grow food and maybe herbs and flowers in our home gardens. We deal with unpredictable weather, droughts, floods, sometimes even snow, and heat waves to cold snaps. We want to use water wisely and conserve as much as we can, and we want to avoid using harmful chemicals in our gardens. So with that in mind, we hope this presentation will be helpful and interesting at a minimum. So the overview of our program, both Delise and I love soil, and I'll talk a little bit about why. And what is soil? What makes a soil resilient, and why would we want that? Let's go back to the first one.
Sorry.
Back one slide. Yeah, thank you. I'll talk a little bit about basic soil science concepts and how to add organic matter to the soil. And the spoiler alert is that the basic soil science is going to lead us to knowing that adding organic matter is the answer to building resilient soils. So Delise will talk about various techniques: composting, low-till techniques, cover crops, and mulch. So let's go to the next one. Thank you. Why should I care about my soil? Well, this quote, I think it was on the flyer for this class, says, "Humankind owes its existence to a 6-inch layer of topsoil and the fact that it rains." So what do you think? For many of us, it's natural to care about the environment, our whole planet, and soil is an essential key to preserving our environment if we take care of the soil. If we don't, then the soil could become a dust bowl. It could be very unproductive, and our future might look more bleak than it does. So the soil anchors and feeds plants, and it provides habitat for many kinds of living things. Our food grows in it, so it supports life. And so you could say that when we grow the soil grows the plants. And soil is the second largest carbon sink on Earth, meaning that soil sequesters carbon dioxide from the atmosphere. So that's important in moderating climate change. And finally, you've probably experienced this because you're a gardener. It's fun to get dirty. Some studies suggest that a particular microbe commonly found in soil is a natural antidepressant. So let's go on to what is soil. I hope this is, let's go back one.
I want to live in that soil.
Okay, what is soil? It's not just dirt. It's a combination of rock particles, organic material like roots, and an incredibly diverse collection of fungi, bacteria, and animal life. And we will dig deeper, if you don't mind my saying that, to cover some physical and chemical characteristics of soil. What's the difference between soil texture and soil structure? And most exciting maybe is the diversity of life in the soil. So these 3 elements, the texture, the structure, and the organic content, make soil what it is and what it does for us. So let's talk about a resilient soil.
Hey, Debbie, can I just ask, what is this little schmutz here on the right-hand side?
That is, okay, correct me if I'm wrong. I think that is a legume growing with nitrogen nodules along the roots in a nitrogen fixing bacteria, helping the plant to pull nitrogen from the air and attach to the roots. Am I
You think
right?
there's mycorrhizae attached to those roots and
Well,
extending it?
I think
Or-
that's different, but that whole root network might also be fungus mycorrhizae. So
You never
thank
know.
you for asking. First question, zip. What is resilient soil? A resilient soil readily absorbs and holds water. So much less irrigation is needed, up to 88% less water. And resilient soils have good infiltration and resist runoff. So you don't have that annoying situation when you go to water the garden and the surface is dry and the water rolls off the surface and it's like, oh, I'm wasting water now. A resilient soil remains healthy through the seasonal changes of heat, cold, drought, and flood, and resists erosion by water or wind. There's also an increase in fertility because of the organic material in the soil. The organic matter is the secret sauce that holds the soil together, makes nitrogen and other nutrients available for plant uptake, and contains and supports the many beneficial life forms that we find in soil. So this reduces the need for fertilizers. Doesn't eliminate it entirely, but a reduction in fertilizer. You get higher yields and less weeds. More calories per unit area of garden, and who doesn't want more calories? And then the bullet point for more potential income. Well, we're home gardeners and we have a hard time getting rid of zucchini in August, right? Which resilient soils won't change, but I think that the point is that the principles apply to larger operations than home gardens as well. So organic farms are trying to build resilient soils just like we are. Also, resilient soil is easier on the body of the gardener so that we can be resilient as well. It's easier to till, it's easier to pull weeds, and it's easier to harvest. So let's get into some more detail on soil science. So soil has 4 main components. We'll talk about these each. There's the rock, which is mineral particles of various sizes, water, air, and organic matter. And the organic matter, well, let's talk about the minerals first. We'll get back to the organic. The mineral makeup of your soil is something that comes with the territory. You can't do a lot about changing the mineral makeup because the minerals are derived from the rocks underneath or upslope or upstream, and that source is called parent material. So these minerals in the rock particles contribute nutrients to the soil, such as potassium, phosphorus, calcium, and many trace nutrients. The air component of the soil depends on the distribution of mineral particle sizes, which we call the texture, and the structure of the soil, which we'll discuss, and other factors like compaction. The water component is dependent, of course, on rainfall and irrigation, and the water may fill up some or all of the air spaces so that you could have much less air and much more water. Or the water might be present just as a coating on the soil particle surfaces where it's held by capillary forces. Organic matter also efficiently holds water. So the more organic matter you have, the better your soil can retain moisture for your plants. And the organic fraction of the soil, the little pie piece that's pulled out there, has 3 parts: living organisms, and residual roots and other plant and animal parts in that little pink slice, and humus. And later we'll describe these 3 types of organic material as living, dead, and very dead. So we can look forward to that. Humus, let's go back one. still. I'm going to describe what humus is so that we can refer to it throughout the presentation. Humus is the end product of decomposition of plants and animals. And humus in nature is usually found in the top few inches of soil. As an example, you can tell when your compost has decomposed into humus because you won't recognize the raw material you put into the compost anymore. Humus is usually dark brown or black and has a crumbly, spongy texture. And humus is our friend, as we'll talk about later. So now let's talk about the mineral content. Okay, so these are the rock particles that are derived from the parent material. Like pizza, the mineral particles come in small, medium, large, and extra large. The range of particle sizes defines the soil texture. The largest particles for our purposes are called gravel. The next largest is sand. The next is silt, which is barely visible depending on your eyesight. And finally, clay, whose individual particles are so small that they can only be seen with an electron microscope. So the soil texture affects how water moves through the soil and the size and the continuity of air spaces. The size and type of mineral particles are formed by geologic processes. So if you think about Hawaii's Big Island, the geology there is massive, fresh lava flows, lacking soil development in many areas, and very thin soils in other areas, versus the Mississippi River Valley, which is also known as Old Muddy, so you can imagine what the soils there look like. So different settings produce different soils. Depending on where you live, your soil may have a larger proportion of gravel, sand, silt, or clay. But no matter what kind of soil you have, adding organic matter is going to make the soil more resilient. So let's talk about soil texture a little bit more. This is a picture of a mason jar, and we'll talk about that in a moment. So the soil texture is defined by the percent of sand, silt, and clay that's present in the soil. So how can you tell? One way is by the appearance and the feel of the soil. Sand feels gritty, and you can see the grains. Silt particles are like the size of flour like you bake with, not the kind that grows in your garden, and generally too small to see with the naked eye, but it feels smooth between your fingers. When silt dries, it's usually fairly soft with a crust that is easily broken. Clay particles are microscopic, so you won't see the individual particles. But when clay is moist, it's slick or sticky to the touch, and it's moldable. And when clay dries, it's really hard. So think of potter's clay. So if you squeeze a handful of moist soil in your hand, a sandy soil will readily fall apart, while a clayey soil will stick together. Silty soil will also hold together, but it won't feel sticky, and it'll crumble easily. Most soils are a mixture of particle sizes, covering the range from loose to crumbly to sticky. Another way to determine soil texture is to put about a cup of soil into a mason jar, like we see here. Fill the jar with water, shake it up very well, and then let it settle for a day or so. And the sand will settle out first, then the silt, and then the clay. And the clay might take a day or more to settle out. There might still be some in this picture in the gray water at the top of the photo. So, but you can see the grains in the sand, and you can see that the silt just looks like a dark layer, and the clay, kind of hard to see, but it's lighter in color, and it's a very thin layer. This is just an example of the soil. It's not, classic soil from everybody's backyard. So if you want to figure out those percentages, you would take the thickness of the soil, the column, the top of the clay layer to the bottom of the sand layer, and you would do some math with the thickness of each layer. So like the 2 inches of silt in 5 inches total soil thickness in the jar will give you 40% silt. And a 1/4 inch of clay in 5 inches total would give you 5% clay. So I'm going to work with those numbers that we saw in the mason jar picture. 55% sand, 40% silt, and 5% clay. Are you with me? And note that those add up to 100%. So that's a good thing, so that when you put so when you put your soil in, you put in 100% of your soil, and then your percentages add up to 100%. So this colorful triangle can give you a name for your soil texture. And you can see that on the left side of the triangle, the percentage of clay goes from 0 at the bottom, and there's not a 0 on the picture, but there could be, and it goes up to 100 at the top. The percentage of silt starts out 0 at the top and then goes down to 100% at the lower right. And then the percentage of sand, thank you, it has a 0 on the right-hand side, and then going to the left goes to 100% sand. So to make it easier for us to evaluate this particular soil, the 55, 40, and 5, I drew some lines on here to show how to use this. Starting with the sand, the 55%, if you see on the bottom of the triangle, between the 50 and 60, there's a blue line, and that's 55% sand. And then for the silt, it's 40%. So you go to the right side of the triangle, go to the 40, and there's a pink line that I've drawn down to the other side of the triangle. And for the clay, it's only 5%. So it's going to be down at the lower part. And it's a green line starting at 5% and going across the bottom of the triangle. And they all three intersect at the same spot, and that tells you what kind of soil you have. Sandy loam. Congratulations, happy gardening. Sandy loam is great to work with, right? So as we said, soil texture it affects the way water moves through the soil, how long soil stays in, how long water stays in the soil, and how easily plants can send roots through the soil, the size of the air pockets, and more. And so your soil might be anywhere on this triangle, but you know, whatever it is, that's what you got. If you aren't happy with your soil texture, that's too bad, because it's hard to change soil texture. But you can enhance your soil's resilience and suitability for gardening by improving its structure, of course, by adding organic matter. So let's talk about, that's maybe enough about the soil texture, but let's go to soil structure. And the soil structure, if the cat walks across the screen, I'm sorry, cats are uncontrollable. So the soil structure describes the way that the individual soil particles clump together. The mineral particles clump together to form aggregates. That's what we call these little clusters of particles. So you can see two examples here, the brown sand grains and the gray silt grains. And the little rectangles are clay particles. And in between, there's some mineral content. You can see that there's room for air, and you can see that the green stuff is organic matter kind of holding these little clumps together. So you can also see that the air spaces within and between these aggregates. So on the next slide, if you pick up a handful of soil, you'll usually see the aggregates, and in a healthy, resilient soil, you can easily separate them by crumbling the soil. So this is a characteristic of loamy soils in particular, which have sand, silt, and clay present. A resilient soil has well-developed structure, and it's crumbly, or even, you know, some people call it fluffy. Soil structure develops over time and can be enhanced, you know how, by adding organic material. Soil structure can also be damaged, especially in clayey soils. You can preserve your existing soil structure by not compacting your soil and not digging in it or tilling it when it's very wet. So texture is a physical property of the soil, and structure is what develops over time with the interaction of water, air, organisms, and humus. And in nature, this takes hundreds to thousands of years, but we don't want to wait that long, right, in our gardens. So those are the basic physical properties. So I'll talk just a little bit about the chemical properties. Next slide, please. Okay, to be honest, we're not covering soil chemistry in very much detail today. You may be familiar with macronutrients like nitrogen, phosphorus, and potassium, and the importance of pH. And Delise will touch on that as well in her presentation. For this section, I'll just talk about cation exchange capability, or CEC. Many plant nutrients, including potassium, calcium, and magnesium, are cations. Cations are positively charged, so they stick to negatively charged particles in the soil. Clay and humus are negatively charged, so let's give them a shout out. They attract the cations. What it really means is that these certain nutrients, the cations, love clay and humus. They're attracted to them. It's chemical attraction. So the negatively charged clay and humus are useful for cation exchange. And this is the process that makes the cation nutrients in soil available to plants. So another way to look at the positive negative aspect is to think about a piece of Velcro, where clay or humus is the side with the little hooks, the negatively charged, and potassium or calcium or magnesium, the cations, are the side with the loops, and you put them together and they stick. So since they're stuck like that, how you get the cations out into the soil water so that the plants can take it up. So think of the plant root, which is pictured here. It's respiring or breathing, and it exudes carbon dioxide, which ultimately breaks down to release hydrogen ions. And the hydrogen ions bump the nutrient cations off of the clay or humus and into the soil solution. Then they're available for uptake by the plant root. So one of the benefits of adding organic material to your soil is increased cation exchange capacity. The higher your CEC, the more efficient nutrient uptake you have for your plants, and the less you have to fertilize. So this is another characteristic of a resilient soil. So the bottom line is that clay and humus in the soil make nutrients more available to plants, and you can increase the CEC, the cation exchange capacity, by adding organic matter to the soil. So far, so good. Let's talk about organic matter. That's the secret sauce that I keep talking about. So it's great for building resilient soil. Organic matter in the soil is carbon-rich material. It may be living organisms, or it might be plant detritus or animal waste, and it may be decomposing. It creates a favorable habitat for the tiny organisms, and it also physically adds chunks of stuff that make air and water pockets. When fully broken down, as we talked about, it forms humus, which acts as a binder to improve soil structure. Also, organic material in general makes soil fluffy and easy to dig, easy for roots to penetrate, better for nutrient availability, and it holds water and it improves drainage. So we mentioned the living organisms in the soil, but what are we really talking about? Let's go to the next slide. There are we'll just talk about three types of organisms that are commonly found in the organic matter. There's decomposers, it's macrofauna, like earthworms. They eat the plant residue, they aerate the soil in the process, and they excrete nuclear-rich casts. And some of us maybe have worm composting at home, and so we can see this, we can see it in action, that they're decomposing the kitchen waste that we put in the worm compost bin. Then there's saprophytes, which are bacteria and fungi that eat decaying plant material. They recycle this material into nutrients and humus, and they make the nutrients available to plants. And then there's the symbionts. I don't know if I'm pronouncing that right, actually. They're parties in a symbiotic relationship where an association or relationship between two different species is beneficial to both species. So going back to that picture that Delise asked about, it might be nitrogen-fixing bacteria in legumes, the bacteria that enable the plant to pull nitrogen out of the air and fix it in nodules in the root system, where the plants get nitrogen and the bacteria gets carbohydrates from the plant. Or the mycorrhizae are another great example. They're the beneficial associations between fungi and plant roots. And the fungus actually sends tendrils called hyphae into the roots. The fungus gets carbohydrates from the plant. At the same time, the fungus improves the plant's absorption of some nutrients. And so the plant benefits. So mycorrhizal associations are present with over 75% of terrestrial plants. So they're probably in your yard, probably in your garden. There's a huge web of mycorrhizae under our feet, not benefiting just a single plant, but even connecting plants in massive networks. So you might see the white filaments in your soil or in in decomposing material, and it's a happy making site. So let's see some of those decomposers and saprophytes in action. It's an action shot, so we'll park here a little bit. Biological tillage in action. This is what happens on the forest floor in cross-section, of course. The organic matter contains living organisms, fresh residues, and well-composed residues. These three parts of the soil organic matter have been described as the living, the dead, and the very dead. So it's a fun way to think of this. The living is, of course, the wide variety of microorganisms and the earthworms, the insects, the plant roots that are alive, and even the moles and gophers that live in the soil. The living organisms feed on plant residues and manures, and in the process, they mix the organic matter. You can see the mixing going on there into the mineral soil. And in addition, they recycle the plant nutrients. The earthworms and some fungi also help to stabilize the soil structure. So we talked about how important soil structure is. So that's the living portion. Let's talk about the dead portion. That's the fresh residue, the recently deceased microorganisms, the insects, earthworms, old plant roots, crop residues, and recently added manures. In some cases, just looking at it is enough to identify the origin of the fresh residue, like a grass clipping or a dead leaf or an insect body. This part of the soil organic matter is the easily decomposed fraction. This fraction is the main supply of food for the living part of the organic matter. I'm going to have to move the cat just one second. Okay. She liked the part about cations. Sorry.
Yeah.
So the decomposers and the saprophytes eat the dead portion, basically. And so as the organic materials are decomposed by the living fraction, they release many of the nutrients that the plants need. And then also they contribute to soil structure by creating various chemical compounds. So the very dead is the well-composed organic material. It's the stable end product of decomposition. And it's the humus that binds the soil particles into aggregates, makes nutrients available to plants, absorbs water readily. And as we keep saying, humus is an all-around very good, very dead material. So let's talk a little bit more about the organic matter on the next slide. There are more, this is interesting, there are more living organisms in a teaspoon of soil than there are people on Earth. So there's a lot of little stuff in that teaspoon of soil. And then these numbers in the table list what lives in 1 gram of healthy soil. So you can see these incredibly large numbers. And these are all found in a healthy soil: bacteria, actinomycetes, fungi, yeast, protozoa, algae, nematodes, not to mention earthworms and, gophers as well. But most of these are beneficial, but there are some disease-causing pathogens that can be present among those 500 million bacteria, for example. So what about those bad actors, the pathogens? Just like the human body, a diverse community of organisms improves immunity, and so a resilient soil with a diverse biotic community can be immune or resistant to certain soil-borne diseases. So that's another characteristic of our resilient soil. So I'm just going to sum up what I've covered, and then we'll move ahead. We talked about the soil texture, how you can determine how much sand, silt, and clay there is in your soil, and how to find a name for it on that colorful chart. We talked about the structure that that allows the particles of soil to aggregate and create a great environment for the living organisms, and then the importance of organic matter. So have we convinced you that a resilient soil is alive, that organic matter really matters? And so if so, let's talk about how we can increase the organic matter in our soils. Delise will explain more, and I hope you'll get excited about trying some of these ways to build resilient soil. So thank you very much.
Thank you, Gibby. That was incredible. Great delivery of very complicated matters. Speaking of matters, I think I have at least 6,000 gophers in 1 gram of soil in my backyard. Those numbers are correct. So, you know now that organic matter is critical to having a resilient soil, and how do you actually get your hands on some of that? Well, as we discussed, soils are formed over time, lots of time, big time, through climate, the parent material, topography, and organisms. We want to speed that process up by imitating nature, which is also called biomimicry. So on a forest floor, this is a typical example of soil formation. The leaves fall, they lay on the ground, the little worms do their thing in biotill, and eventually it turns into earth after thousands of years. The other way that we've seen this, another classic way that's observed, is in the prairies. Huge diversity of plant life with different root structures, deep and wide, growing very close together, trampled by ungulates in a perfect world, but we killed most of those, so that's the buffalo. And then snow comes, the plants lie down and die. They stay on the surface of the soil, and every year after year after year, this builds up into a beautiful humus-rich soil. But again, thousands of years. So you're going to do that. Just a little diversion here. We have been talking a lot about how adding compost and improving your soil will help with drought. And when I've taught this class in the past, it's been all about drought and how can you keep the water in your soil, and compost was for that. Well, compost is also provides other functions when other weird things happen. So I'd love to see how many people, if you could raise your hands, how many people were experienced some kind of flooding in the January floods. Can anybody? There's Susanna and Elisa. Had that happen to them. I'm not able to see everybody. Karen, a familiar name again. Seen you recently. Okay, so thankfully not all of us, a few of us, but it's a thing that's happening nowadays. So depending on where you live, it's good to know what happens to your soil if it's covered by standing water for any length of time. So standing water is it's gonna cut off the oxygen to the soil. So all that little bacteria and biotic life in the soil, it suffers greatly and or dies. The roots of the plants are also impacted, and plants may die. It stresses the plants, which also invites fungal or bacterial disease. If the water is coming from an upstream source, it could be importing pathogens or chemicals, or, I think of San Lorenzo River and the septic tanks upstream and people flooding downstream. It can be bad. Having too much water on your soil can lower the pH. An inappropriate pH can reduce the ability to do nutrient uptake for a plant. So that's a factor, and it can also just wash the nutrients away. What you would do if you were in this situation, the best ways to ameliorate this, and we do have a couple of links in the appendix at the back of the slide deck, which will go out to you all in a day or two, is you wait for the water to recede. And if it doesn't go away within a day or two, you can trench around the edges and try and divert it to places where it's not doing as much harm. Don't ever eat produce that touches the ground. So any kind of lettuce, anything that's touching the ground in a flood, you're just gonna let that go. I don't think it's gonna look too good anyway. Tree fruit is okay. If it's not sitting in the water, it should be fine. Don't ever walk on it. You don't want to compact wet soil. You don't want to work with wet soil. Any soil that is so wet that if you put a shovel in, dirt sticks to the tool, then you do not want to be turning or messing with that soil, because it'll ruin any aggregation you have going on with the particles. So you want to let it dry for a couple of weeks, hope it doesn't rain more, and then add compost and mulch. Compost kind of inoculates the soil from anything that was imported and will help improve the overall health and reduce the pathogens that may have come in. And then get the soil tested. I cannot recommend that highly enough. And I'm going to give you some tips on how to get that done. But first, we're going to take another sideline here. Let's talk about nutrients, because we're not talking about nutrients in this class very much. It's a complicated conversation. We did talk about the chemistry of how nutrients are taken up, and that's the important takeaway for this class. But if you don't know already, there are three macronutrients: nitrogen, phosphorus, and potassium. And on any kind of fertilizer you purchase, these numbers go in the order nitrogen, phosphorus, potassium. K is for potassium. We don't understand that, but that's what it is. So these numbers are always in the same order, and these are proportions of those nutrients inside the bag. You always read the bag and use it accordingly. Don't over fertilize, because that's a waste of money, and it can pollute waterways if it washes away. You want to find out your starting point. So you want to know what your NPK is before you start a garden, or at the beginning of each year is what I do. You want to get the pH tested. You want to know how your micronutrients are faring. And this micronutrients are many. There are lots of them. Iron is one, sulfur is one. There's a whole bunch of them. I'll show you a picture in a minute of a soil test report. And micronutrients are important. Some are more important to others. For example, iron in lemon is an important micronutrient, and without it, it gets a chlorotic yellow leaf, which yellow leaves can be for any number of reasons, but in lemons, we always check for that. And a soil test, a good one, will give you a % organic matter. So let's look at how you go about doing that. So we as Master Gardeners don't recommend any particular vendor of any particular sort, but we do offer this list of soil testing labs, and it is a long, exhausting list of labs in California. The first one is A&L Western Labs. I use that one, and that's what this report came from. And there's just a couple of things I want to point out. You can't really read it. And if you don't know how to read it, you really can't read it. But it's small. But the scale of the bars goes from very low in the blue to very high in the red. And you can see this was actually my native soil. I had never grown anything on it. It's in a back corner of my property. There was a bunch of junk sitting on it and I never touched it. So I thought, hey, let's see what's going on if I, what did I start with here? So the organic matter was pretty low, 2.4%. A good organic matter number is about 4 or 5 in an agricultural setting. So not a whole lot of, the weeds did not provide a lot of organic matter in that particular corner. Nitrogen, ooh, very low. And this is typical because nitrogen is the water soluble nutrient. It just goes away with the water. So if you're not adding it, it's a thing that you need to keep an eye on. And nitrogen, phosphorus, and potassium are all nutrients that every plant needs. The micronutrients, less so and less of it. So phosphorus in California, we tend to have high phosphorus, and this shows out. These two bars are high phosphorus, very high phosphorus. Potassium also very high, and that is not unusual for this area. So this is typical of my region so far. But then I was surprised and pleased to see all these micronutrients. Well, that's cool. I guess they're available. Now you don't want too many micronutrients. Some things can, like copper, boron, they can, they can provide some toxicity to certain plants, and it's not always the best thing in the world, but this is just what was in the dirt. Looking at the pH here, it was 6.2. That's a little bit on the low side. I'd like it to be a little higher. And in fact, they gave me some recommendations. So down here it says liming may be necessary to buffer the pH. So I'm not a person who adds lime. I'm a person who adds compost. That was the native soil. And then I tested some soil that I'd worked for probably 10 years, added compost every year. So this one, organic matter was through the roof, very high at 7.0. Nitrogen, still very low, not as low, but I need to add that all the time. It's a thing I know. And if I didn't do this test, I just wouldn't know that. Phosphorus and potassium are still really quite high, and that's interesting. So that just tells me my native soil is high in those nutrients, and it's not a mobile nutrient. It isn't, oh, I forget what the charge is. It's not, help me out, Debbie. Whatever it is, the charge does not carry away with water, so it's going to stay put.
Yeah, potassium is positive.
It's positively charged, yeah, okay. Calcium, I have chickens, I add a lot of eggshells, maybe the calcium is high here, higher than it was before. And then all my micronutrients went away. I don't quite know why. I'm thinking that probably the plants utilize them. So that may indicate that I should add a micronutrient mineral mix. My pH went up to 7.0. And that just shows the change in soil profiles and test results between, native soil that's unamended and soil that you've worked for a couple of years. So always helps you buy the right things and not buy too much of the wrong things. So I don't need to buy phosphorus. That's what I know. So whenever you're adding organic matter, there's always a trade-off between time, money, and the muscle you're going to put in. So depending on your position in life, you can take different approaches. We're going to start with compost. That's the easy one. You just, put it in, buy it and put it in. And then we're going to talk about some other techniques. So I always add it twice a year, and there's lots of places you can get it, and it comes in different sizes and shapes and containers. I'm sure everybody's seen bagged compost. You can go to mushroom farms and get it front loaded. You can go to stables, and if you ask for composted, you don't want fresh horse manure. Yeah, you can do that. So there's trade-offs with all the materials you can get commercially. The best idea is to make your own. At a mushroom farm, they want to inhibit the funguses that they don't want to have grow, so there's fungicide in it potentially. In stables, if your manure you're getting is too fresh, then you get salts, and it can change the pH and cause problems there. If it's bagged, you have to have something to transport the bags, and it becomes quite expensive. If it's from the green waste landfill, the recycling center in Watsonville, I go there sometimes to get my truck front loaded with compost. That you just do not know when in there what happened. So whatever went into somebody's green waste bin goes to the center, gets composted, and it's hot composted and all that. But I'll find pieces of glass and metal and different things just show up in it. So that's a potential for importing weeds or strange things. You always want to check the ingredients with any commercial, and I'm just going to show you. Can everybody see this? Is it working? Hello?
Yes, it is.
Somebody answer. You have to stay off mute, my dear. So I went to Aptos Landscape Supply just to kind of show what this is one of the ones that I think is a pretty good commercial compost. It's got humus and rice hulls and straws and grape pumice, some mushroom compost went in there, and some chicken manure. You don't want to use fresh chicken manure because that can nitrogen burn your plants, FYI. But check the ingredients is the point there. Check the ingredients. Oops. All right, now here's the trick. How much is it going to make a difference? It doesn't take thousands of years, but it does take a couple of years to really build good soil. And I would say 3 years is a good amount of time to keep doing the right stuff to the soil throughout the year. And then you will have pretty darn good soil no matter what you started with. So if you were going, if you're starting from scratch, if you're doing that back corner of mind that I actually did start cultivating and now grows beautiful produce, a 3-inch layer is a good start. But a 3-inch layer is a whole lot of material. So 3 inches over 100 square feet is 12 2 cubic foot bags. That's 24 1 cubic foot bags, or 1.3 cubic yards if you have a truck. I've added for you here this little coverage calculator where you can say, I want to add 2 inches. I have 1,000 square feet. And it calculates and tells you how many of what. This can't be right. Let's do 100 square feet. See if that looks better. No, that's about right. So 1,000 square feet. I always recommend you start your first garden small. That would be 167 1-foot cubic foot bags. That would be a lot. That would be expensive. So make your own. And there will be a composting class later this year. And Debbie might be part of that. Who knows? So think about your starting point. Has your soil never been worked? The best deal is to import a lot of organic material, as much as you can carry and afford, and then dig it in as deeply as you can. And even though the top 6 inches are where all the biotic life and action happen, because that's where the oxygen is, and the biotic life needs oxygen to do what it does, you still want to loosen the soil deep if you possibly can. So that's why you dig up to 12 inches the first time, if you possibly can. In year 2 or 3, you continue adding organic matter. Something you always do is try and keep the soil covered at all times. When I say covered, that means mulched, or it means you're planting the plants, say butter lettuces. close enough together that their leaves touch. So there's always a little umbrella of leaves and shade that's protecting the soil surface and keeping the water in the soil. Or you are mulching. So mulching with an organic material on top of the soil is how you keep it covered. Or growing a cover crop. I think I said the same thing twice, didn't I? And then after 3 to 5 years, things are getting better. You can start using no-till techniques, which are really low-till techniques. We'll talk a little bit about that, but you can't start out using low-till techniques with soil like your one. Okay, so first year strategies. Import that compost and double dig or cultivate as deeply as possible, and then cover crop in the winter, chop it up, dig it in, and let it decompose in the soil, and then wait a month and start planting. And you don't have, excuse me, you don't have to wait until winter to do a cover crop. There are winter and summer cover crops, and we'll talk about one of my favorite summer cover crops shortly. If you are as lazy as I am, you will consider a straw bale garden, which is something that takes a little time, but you still get to get a crop out of it right away. And after 1 to 2 years, you get a really beautiful little space of organic material and nicely amended soil. And I'll show you pictures of that. Or you can do what we call lasagna gardening or sheet mulching, which is layering straw and cardboard and leaves and manure in perfect little layers that are, air flows between them, and you keep them moist, and you put some soil on top. And so while the bottom of that little sheet mulched bed is decomposing, your plants are growing on top. And what you get out of the end of the deal, you have to collect all those materials. That's the hard part. And the easiest time to do that is the fall. So that I recommend that for the fall. Actually, both are best to start in the fall, but you can do them anytime. So these are the kind of things I mentioned in the chat that Debbie is considering doing an in-person class about these techniques. Forgive me, I'm getting over a cold. And these would be the kind of things that we would demonstrate in person. So we'll take a poll on that later. Okay, here's a straw bale garden. There is a whole class on straw bale gardening. Anyone who's interested, we can send them a link to the material. Basically what you do is you take the straw bales. This one is 4 bales put in a circle, or basically a square. And I filled the center part with potting soil. And then you plant in the middle and you water the bales for a couple of weeks. You fertilize them with blood meal or some high nitrogen fertilizer. And then it softens up and the bale begins to decompose. I'm so sorry. And you can dig into it and you can plant directly into the bale. It seems really insane. It seems like it would be dry and it would just like take so much water, but it's not like that. So here it is. 6 months later, it's decomposed to half its height. It's falling apart. It's not going to show up in Garden Beautiful, but it works really well. So this is a second crop in that same straw bale garden. And I get 3 or 4 crops a year out of one of these things. Here we have a year and a half later. It's about 6 inches high. I'm still putting little lettuces and spinach in there. And after I took this picture, I basically raked up the edges and surrounded it with some bricks. and turn it into a little raised bed without ever turning soil. Lazy, really fun, really easy. So low till 2 years. I think I've said all this. I'm just gonna say it again. You want to compost a couple times a year, and you want to add at least 1 to 3 inches every time you add compost. Keep the soil covered with plants or mulch. Cover crop when you have fallow time, and compost the tops or add them to the soil. And then cultivate the top 2 inches as needed, because weeds happen. And you can use a little skimming tool or a little hula hoe. This is very, very embarrassing. I'm sorry. I'm so having this issue. Next. And year 4, you can dial it back on the compost a little bit at a certain point, as long as you're keeping the soil covered and keeping that cover crop. Leave it on top, chop it up and leave it on top of the soil. But eventually you're gonna have to fluff it up. So even a no-till / low-till garden will need to be aerated at a certain point. And this is a special tool that allows you to sort of fluff the soil up without inverting it, without turning it over, which is a thing that breaks up your soil structure and your aggregate building. Okay. The benefits of low till are that it reduces the weed pressure at garden scale. I say at garden scale because from an agricultural standpoint, weed pressure is probably the biggest problem. It retains stable soil carbon. Every time you turn soil over, carbon burns away. Oxygen makes it burn. It makes it basically decompose and volatilize into the air. So if you're not turning the soil over frequently, you're keeping more carbon in the soil. It maintains and builds good soil structure, preserves those intense mycorrhizal relationships that Debbie was talking about that are going on under the soil all the time. It helps the little earthworms be happy while they're busy biotilling your soil under the covers, and saves water while improving drainage. Problems are it can be a haven for slugs, snails, and earwigs in that mulch. Another thing is that mulch cools the soil. So if you're mulching in the spring, that can mean a slow start for things like tomatoes that want to have warm feet. At farm scale, like I said, weeds are the big problem. And like I said, eventually soil will compact. So you have to keep it fluffed up. All right, I'm on camera coughing, and I'm going to, what am I gonna do? You know what? I'm just gonna go out of view and blow my nose. All right, sad but true. That's my career in the movies. Let's talk about cover crops a little bit. It's my favorite thing to do in the world. So cover crops they're the hardest working plants in garden business. They suppress the weeds. That's the best thing they do. They add organic matter. They protect the surface of the soil and keep it light and friable. They penetrate the soil with their roots, and they loosen hard soil. If you have a slope, they can prevent erosion. They enhance the mycorrhizal populations and the whole water thing, retention and infiltration. So I wouldn't go a year without cover cropping, frankly. But why specifically are you cover cropping is the good question. I see we are over time, and I apologize. It's all this hacking. So let me see how fast I can go. Um, if you need nitrogen, you might want to plant a legume. If you need to attract beneficial insects, you might want to plant something and leave it until it's flowering. If you're trying to loosen heavy soils, you might want something with a, a really penetrating or matting root. If you're, yeah, there's lots of reasons to grow cover crops, and you can you can grow them for multiple reasons and harvest them at different times for different reasons. So key cover crops are legumes. These are all the bean family, and fava beans are popular. Bell beans are a close second. They are the ones who fix nitrogen nodules and suck it out of the air and do that symbiotic relationship with bacteria. They are wonderful, but the roots are not so vigorous that they really penetrate the soil and break it up. So that's what I know about that. I'm not going to talk about the nitrogen cycle because I could go on too long. Cover crops, cereals. So cereals, as in oats, rye, wheat, they have really wide spreading matting fibrous roots, and they really break up the soil nicely. So they don't add nitrogen. They add some nitrogen if you dig them in, which it's kind of hard to do, especially if you let them grow too long. And I have to say about the fava beans and such, don't let them get woody, and don't let them grow too long in the soil and then have a hard time digging them in. Wait, you'll leave them, make sure they're soft and pliable when you're digging them or cutting them down. They provide lots of biomass. And you can feed them to your ungulates. I know you have goats, right? Brassicas have a special niche. So daikon radish biodrills, literally biodrills, just digs a big old hole because it's a big long radish. And if you can figure out a way to incorporate that into the soil with a rototiller, some kind of heavy equipment, I'm thinking, that's great for really heavy soil. Mustards, they have found, have some inoculating properties. So a secondary compound is exuded from the roots, and it's known to impact populations of non-beneficial nematodes. So this is a great thing if you're having diseases, if you're having root knot nematode problems, that would be a crop to grow. It grows really fast. It's really easy to turn in. You do need to incorporate it into the soil and not cut it off and compost it for it to do its inoculating thing, and it will only last one season. So that's just a tip. This is my favorite cover crop of all time. It's called buckwheat. It is a summer cover crop. All those other ones were winter cover crops. It grows incredibly fast. Within 35 days, you've got this field of flowers. Bees love it. It's really soft and easy to dig back in. It pops out of the soil on a warm day, and it doesn't it doesn't fix nitrogen, but it's great for all kinds of other reasons. Make sure you do the annual buckwheat and not the perennial buckwheat. So here's a picture of buckwheat growing in a space. Whenever I have kind of a hole in my garden, I've harvested something, or there's a bare space, I'll throw a little buckwheat in during the summer in between plants, because it's just doesn't do any harm. Here's buckwheat on the right, and here's some older buckwheat on the left. I've covered it with a silage tarp. It's just a thick milled black tarp that helped it decompose faster. So I'm always in a hurry to get something planted in the soil. So if I chop the cover crop down at the root zone and then let it lay down on the ground and cover it with a tarp, it will heat up and decompose pretty quick. The spare soil you see over here is a result of a gopher, and they seem to like to come up under the silage tarps. So that gives you the opportunity to trap for them. Okay, so there's my gopher mound, and here is the kind of dried and partially decomposed what is now mulch, which was buckwheat. And here in this little inset on the lower left, you can see some roots or some weeds. These are weeds I don't love. I've pre-germinated them by using that tarp. They come up in the dark, and you can pre-germinate them before you plant, and then you can pull them easily, and you have improved your weed problem. And this is an example of a little broccoli plant that's planted directly in the cover crop that was cut down and left to lay on the surface. So you don't even have to dig it in. This is a no-till method. This is an example of a mix of seed. It's diversity, as we've learned, in your gut biota and in the soil, everywhere you look. In the politics, diversity is good. So you can get a mix of different seed types, and it covers a lot of bases. This is a great little tool to help you pick seeds for different purposes, and it will put together a mix of 3 different types of cover crop seeds. I'm not going to go over the planting. And we'll quickly talk about what do you do at the end. If we do have this class in person, there will be some cover crop planting and chopping. So when you're ready, you chop the greens you can do a weed whip, you can do a shovel, you chop them at the soil level and just cut them down. Then you can leave them on the surface for a few days to kind of wilt down, and then dig them in. If you do that, you have to wait a couple of weeks to plant. Another option is to take the tops and put them in a compost pile, and water. You want to leave the roots in the soil, especially if you have a legume in there, and wait for a week and plant after that. And then option number 3, leave them on the surface, chop them up, just up and down with your shovel, chop them and cover them with black plastic. That's optional. Plastic is bad, we know this, but then you can plant directly into the mulch that you've just created. If you're going for the nitrogen in the legumes, you want to cut them before or just as they are blooming. That's when there will be the most nitrogen in the soil. If you wait and you let them bloom in fruit, they will use that nitrogen. And then here are some on the right. These are not chopped fava beans. On the left, they're chopped down. I'm cutting them up with my shovel. And in the upper left-hand corner, we have the chickens working. And that's what they should do. You should work, girls. All right. Let's find out who would like to see us do an in-person class for this soil management. Please use your reactions button. And Diane is a winner. Yeah, she would like to have one. Does anybody else think they would come to this in-person class? Let's see, Joanne, thank you. Looking through. Annie's there. She's got a thumbs up. All right, a couple of people. Okay, keep an eye on that on your email for that. Other classes we do have, well, first of all, there's a short evaluation survey, and you will, I'm sure, evaluate my coughing. I'm sorry about that. But tell us how we can do better. And that's coming to you in the chat right now. Denise is gonna send it out. We'll also send it along with the recording of this and the presentation. So that will be coming to you in a day or two. Then expect an email from the California Master Gardener program They send out a survey asking if people use the information that they learned in these classes, and that it helps them get funding. So we encourage you to please answer that little survey. And then we got classes coming. We've got Rose Care coming, virtual and hands-on in different days and different places. And then we have fruit tree pruning. And that's going to be hands-on. There's going to be a morning and an afternoon session. You need to register for all of these on the Master Gardener website. Denise, will you put the Master Gardener website in there? And then coming soon in April 17th to 26th, we have our Master Gardener plant sale. All plants grown by Master Gardeners lovingly as volunteers. Nice selection of plants, happens every year, and it's no contact, so you don't have to touch anyone who's coughing like me. Just order online and then you go and pick them up. And this year we're going to have a pickup day in Watsonville and other pickup days in Salinas where they are grown. If none of this makes sense, or if you have any specific question on any topic garden related, you can use our Master Gardener hotline, and we encourage you to do so. Okay, Denise, what are we talking about here?
All right. There actually aren't too many questions, which may be good. That's probably saying that you guys did such a great job of explaining everything. So there are a couple that showed up during the time that you were talking about the soil testing. This first question, I have no idea, so I'm just going to read it. It says, is this test a strong acid or weak acid morganic extract type?
No idea what that means either. Sorry. What you do, what I do is I take a trowel, basically a cup of soil, put it in a Ziploc bag, put it in a padded envelope, send it off, and then I get an email with the results. And there are different tests you can order. I showed you examples of the basic soil test that they offer, but there are, you can test for toxicities and pathogens and different reasons that you might want to test. So I'm sorry I can't answer your question as stated.
All right, this one should be easier. What's the approximate
Hold on,
cost
my
of
bad.
Oh,
Hold on, let's ask Debbie if she knows what that meant.
I didn't quite understand the question either, but I'd be happy to hear it again. But it seems like it's probably a question for the lab, if it's about what technique is used to, to do the analysis.
Good point.
right. Yeah. Okay. All right. So what's the approximate cost of that sort of soil test?
Well, last year when I did it, it was $35.
There you go. I knew that would be easier.
Much.
All right. So what's the best scale or size for straw bale gardening? You know, any more little hints on that?
On the straw bales or the garden itself? I'm not sure what that.
I would read it
Or
as
not?
the garden itself, but you can add, whoever put that in there, go ahead and add an addition, or if you have a specific
Well, there are
direction
two
you want us
sizes
to go.
that straw bales come in, and I usually use the bigger one. And right now I can't. I have a straw bale presentation that I'm happy to send out as a resource. Oh, new message. Here they go. No, that's not related to it. Anyway, there's two kinds of straw bales. So anyone works. You don't want to use hay. Hay has seeds. Straw is just the stem part of the grass. And you don't want to ever start too big with a garden. I would always start at about 100 square feet and see what works.
All right. Okay, well, that is, wait, hang on. Another question has appeared. Okay, thoughts about when you're planting natives. The recommendation is sometimes to not amend the soil. Thoughts about that?
That is such a good point. This entire presentation is really about growing annuals and vegetables and pretty much non-perennials. So natives are a completely different animal. Thank you so much for bringing that up. No, you would not add a ton of compost to soil that you're not growing lettuce and broccoli in. This is mostly for food gardening, and we should have specified that at the beginning. Thank you.
Look at that. All right. Oh, there. All right. Good clarification there. I don't see any other questions in the chat, so we might be at a place. Look at how well you all did. You explained everything so well.
Okay, hope that's what's going on. I do apologize about the cold. Oh, a perennial
yes.
edible cover crop.
Okay.
A perennial edible cover crop that you can dance on. I'm going to look for a resource for you. It's at Peaceful Valley Farm Supply. And it's a really great cover crop. List of what they are and what started. It's the cover crop solution chart. And this thing is amazing. And can I make it bigger, please? Okay, so it's annual cool weather, warm weather, perennial cover crops, pasture cover crops. So you want a perennial cover crop you can eat? Is that what we're hearing?
That's what it looks like.
Okay. Well, I know that Native Americans in this area ate clover. Ryegrass, native grass mixes. Not a lot of edibles. Alfalfa if you're a cow. Good forage. So excellent food for your pets. But I am not seeing a clearly edible perennial, native perennial in particular. Did you say native perennial?
No, no, that wasn't actually in there.
Okay, I just confused two questions. How about Debbie? You got one up your sleeve?
No, I don't.
No.
Unless you just let the grasses go to seed and harvest the grain.
That is one other Native American diet trick. But you can see the benefits are fixed nitrogen, good for forage, weed competition, erosion control. The annual edible I would do would be the beans, fava beans. People grow that for beans all the time.
Mhm.
Sorry, struck out again. But this is a really incredible little document, this table.
Yeah, that chart is awesome.
Yeah.
Right. Is that by any chance in the resources with the presentation?
It's going to be.
All righty.
Yeah, I'll put it in that email that we're going to send.
All right. I think you've done it.
Thank you, Kari. That was a nice thing to say. And thank you all for being here.
Yes.
Good. Right.
And thank you, Debbie, for taking the plunge and teaching. And Denise, thank you for hosting.
Yes.
Oh, new messages coming, people saying goodbye.
All right.
Thanks, everybody.
Thanks for the opportunity.
Bye.
Really great class. Thanks, everyone.
Bye.
Thanks, everyone. Bye-bye.